We're going to be talking about, in this lesson, a system of linear equations using matrices. Now, I've done two other videos, one on a system of linear equations in two variables, and then I did another one on a system of linear equations in three variables. In this particular lesson, we're still going to stick with using three variables, but I'm going to show you how to use a matrix and row operations to work through those problems. Okay, so we're going to be following the same steps where we eliminate the x term from equations 2, equations 3, and then we eliminate the y term from equation 3, because remember, our goal is to have x, y, z in the first equation, y and z in the second equation, and then z in the third, because then you can back substitute. Well, with matrices, I'm going to show how you can go even further without back substituting and get directly to the answer. Since we'll be dealing with matrices, and you'll hear me say row operations. So on the previous videos, I was saying equation 1, equation 2, equation 3. But when you're dealing with matrices, you actually have rows and columns. So let's just get into it. So the same steps will apply. Your first step is making sure that the x term has a coefficient of 1. You want to eliminate the x term from the second equation. Then you want to eliminate the x term from the third equation. And then you're going to kind of start over. Now you want the coefficient on the y term to be a 1. And then you're going to eliminate the y term from the third equation and then use back substitution. But like I said, in this one, we're going to get all the way to the point where we can use back substitution. And we will do the back substitution, but I'm going to show you how you can keep moving forward with the row operations without having to do back substitution and get to your final answer. So here we're normally dealing with equations that look like this, where you have your x, your y, and your z. The numbers that are in front of the numbers that are in front of the terms, the x term, the y term, the term, that number, those are called coefficients. And then these numbers here are called your constants. Well, you can convert this to a matrix. All you need to do is pull the coefficients and the constants. So you see how that works out. So you have your coefficients and you have your constants. So it gets rid of the variables. So you kind of have, that's why I said it gets rid of the fluff. So you have less to look at. But the cool thing is all you have to work with is the numbers. So your constants are over here. You have a bar. Some people do like a bracket. I just do the bar. When you see me write it, you're probably going to see me write a big bracket. So your coefficients go in here, and then your constants go in here. Your constants are here. See how they line up? And then the coefficients are what's on the terms. You notice if there's a single variable, that's an understood 1 in front of it, because 1 times whatever is just whatever. We don't write the 1, but that's an understood 1. And then if it's more than 1, you'll see it actually in front, and you keep the sign. So normally see how that was a -1z, and so we kept the sign there. When you're talking about matrices, you have you don't want to say equation 1, equation 2, equation 3. You want to specify what you're talking about, whether that be rows or columns. So you have 3 rows because we're doing an equation in 3 variables. And then you also have 3 columns, okay? Or 4 columns rather, if you include the constant. If you're just talking about the coefficients, you have 3, but yeah, so you have 4 columns. So you have rows and then you have columns. And then each individual number that you see in the matrix is called an element. It's an element of the matrix. And when you form it like this or write it out like this, the form is called an augmented matrix. Now, without getting into deep definitions about matrices and all of that, that's going to be another video. Just know that this is called an augmented matrix. And I'll cover all those type of definitions and why they call it that in the other videos. But just know that you can take your equations and you can write them in the form of a matrix, and you can follow the exact same steps to solve the equation. So let's get into it. So I picked a different example. This, I just wanted to show you that you can convert it. Let's just work with a totally different example. So what I've done is I've taken the first equation and I have turned it into a matrix. You will notice that I pulled all of the coefficients from the equations. I kept the signs. Okay, so this represents our x's. This represents our y's. This represents our z's, and anything beyond this represents the constants. Okay, so that's how you write those. So the first step is we want the coefficient of the coefficient of 1 on the x term in the first equation. This says equation, but we're no longer dealing with equations. So, but you're still going to follow the same steps. So in theory, this should say first row. I copied this from my other videos, so I'm trying to keep the same terminology. Just know when I say first equation, I'm talking about this first row. Okay? Second equation, second row. Third equation, third row. First, second, third. No matter what operations you're doing, this is always the first row, second row, third row. Okay? So we want the coefficient on the x term to be 1. Well, it's already 1. So we're doing good. Okay? So step 2, remember the steps, we'll go through it, but we're supposed to be eliminating the x term from equation 2 and equation 3. Let me switch to my iPad so we can look at it together. So I have it written here. Put my passcode in. Okay, so come back over here. I did click it, didn't I? Okay, so eliminate the x term from the second equation, the second row, okay? We want that to be gone. We want that to be 0, okay? So that's what they mean by eliminate. So same elementary operations, except we're going to call it row operations now. So I'm going to write, I'll do it in green again. That seemed to really work. So we're on step 2. I'm going to put step 2. Okay, we're eliminating the x term from the second row. So I need that to be 0. Well, if I can make this negative, and if I add these two together, it'll work out, right? So what I'm saying is, if I can make this negative, a -1, if I add them together, they'll cancel each other out. And that's what we want, okay? So we're going to take -1 times row 1. Now, instead of me writing row, you're going to see me write R. That represents row 1, row 2, row 3, okay? So -1 times row 1, and I'm going to add it to row 2 to get my new row 2. If you've seen my previous videos, you've seen that I write it out what I'm thinking so that I don't lose my spot. And some of you might think, oh, that takes forever. But once you really get good at it, you write it, you do it, you move on. You write it, you do it, you move on. I'm showing you step by step so that you can see it, so you see what the order of steps are. So I'm taking negative, did I do that? Yeah. So I'm taking negative R1, -1 times row 1, adding it to my row 2 to get my new row 2, okay? So -1 times row 1, I'm trying to think how I'm going to do this. Okay, so I'm looking at this row first. Matter of fact, I can go ahead and, no, I don't want to do that. Okay, -1 times row 1. We're looking at this row. So -1 times these numbers, okay? -1 times row 1. So -1 times 1 is going to be -1. -1 times -2 is going to be a +2. -1 times 4 is going to be a -4. And I'm just going to draw the line to show my constant. And then -1 times 6 is going to be -6. So far, so good? Yeah. Okay. Sorry, I was looking at the PowerPoint. Now I'm going to add my row 2. Row 2 happens to be 1, 1, 13, and 6. Okay. We're going to add these together to get my new row 2. When I add these together, I end up with, I'm going to do that in black, 1, 1, 13, and 6. That way I can keep a blue. That's 0. That's 3, 9, and 0. Okay. Yeah, 9, 10, 11, 12, 13. Okay, cool. So this is my new row 2. So now my matrix is going to look like this. We're going to have 1, negative 2, 4. I'll come back and write the constants. 0, 3, 9, and then negative 2, 6, negative 1. My constants, this is 6, 0, and negative 10. Okay, so that's what it looks like after, after that. So we changed the 1 became a 0 because we eliminated that term. So you don't want to leave a space. You actually want to put a 0 like kind of like as a placeholder, okay? So now, step 3, we need to eliminate the term from the x term from the third equation. Okay, so that means we're looking right here. We need this to be a 0. Okay, well, again, if I can make this a 2 and I add it to this one, 2 plus negative 2, that's going to be 0. So let's do that. So I'm going to take row 1, 2 times row 1, add it to row 3 to get my new row 3. Okay? Negative 2 times this row, so I can add it to this row so I can get a new of that row. Because if I can make that a 2, 2 plus the negative 2 will be 0, and that's what we want. Okay, so let's do that. Get a real pen. 2 times row 1, added to row 3 to get my new row 3. So 2 times row 1 right here. So 2 times 1 is going to be 2. 2 times negative 2 is going to be negative 4. 2 times 4 is going to be 8. So far, so good. 2 times 1, 2. 2 times negative 2, 4, negative 4. And 2 times 4, 8. And 2 times 6, 12. Let me do it like that. Okay. And then add that to row 3, right? Row 3 is negative 2, 6, negative 1, and 10. Negative 2, 6, negative 1, and 10. Sorry. Yeah. And then these cancel, which is what we want, right? Sorry, I was looking at that one. These cancel, which is what we want, but I'm going to make sure I write that becomes 0. A negative 4 plus 6, that's going to be 2. 8 plus a negative 1 is going to be 7. And 10 plus, negative 10. Excuse me. Y'all see that? Negative 10. So negative 10 plus 12 is going to be 2. Get my blue. So this is my new row 3. Okay, so if I write the matrix, my new matrix, I have 1, negative 2, 4, 6, 0, 3, 9, 0, and 0, 2, 2, 7, and then 2. So far, so good. You following? Okay. So 1, 0, 0, negative 2, 3, 2, 4, 9, 7, 0, 6, 0, 2. Okay, so now we eliminated the x terms from equation 2, row 2, and equation 3, which is row 3. Now remember, the next step is we need this to now become a 1. We want the coefficient on the y, to become a 1. Remember, make it simple, don't make it hard. Do the easiest operation that you can do. If I want to turn this into a 1, I can just divide it by 3. So there's no need to jump to these other rows to do that. You could, but I just need that to be a 1. And I need this to stay a 0, okay? I don't want it to magically come back. So that's why I'm just going to divide by 3, Okay, so we're going to take, this is step 4. We're going to take 1/3 times row 3, row 2, and we're going to get our new row 2. Okay, 1/3 times row 2. All right, so that means if I write everything over 3 divided by 3, 1/3 times it is the same thing as over it. So that would be 0 over 3. That would be 3 over 3. That would be 9 over 3. And then this is the constant 0 over 3. And when you simplify this, of course, this becomes 0. This becomes 1. This is my new row 2. 0, that becomes 1. That becomes 3. And that becomes 0. So that is my new row 2. 0, 1, 3, 0. Okay, 0, 1, 3, 0. So far, so good. Okay, let me write the new matrix just like what we see there. So now when I write my new matrix, I still have 1, -2, 4, and 6. I now have 0, 1, 3, and then 0, 2, 7. Let me write my constants. I'm trying to keep the constants as gold because I want you to see that they're different from the coefficients. Okay, that's the only reason why. I just want you to see that they're different. Okay, cool beans. Let's keep it moving. So now that's step 4. Step 5. Now we need to eliminate, right? We need to eliminate this because we want to have, remember our goal is still x, y, z, have a y and a z, and then have a z because then we can back substitute to get our answer. So far this looks good. So far this looks good. Now we need to get rid of the y term in the third equation or the third row. So that's going to be step 5. Okay, so if I want to get rid of this, meaning I need this to become a 0, do you notice what 2 equations we can add together really quickly? You got some options. Now here's the thing. If I add this equation with this equation to get my new row 2, the problem is this is going to turn into 1 because of that. We don't want it to turn into a 1. So let's work with these 2 equations because this will stay 0. Remember, that's our goal, and we want this to go away. So it looks like, it looks like we can take -2 times row 2, and we could add it to row 3 to get our new row 3. Okay? Yeah, because then this will still be 0, which is what we want. This will turn into 0, which is what we want, and then we should have that left. Okay? So let's do that. So -2 times row 2 plus row 3 to get my new row 3. Okay, so -2 times row 2. So we're looking here. -2 times row 2. So -2 times that, -2 times 0 is going to be 0. -2 times 1 is going to be -2. And then -2 times 3 is going to be -6. And then we have our constants, right? And then -2 times 0 is going to be, real pen, 0. Okay, and then our row 3, I'm just going to write it, 0, 2, 7, 2. When we add those together, we get 0, 0, which is what we want, 1, and then 2. Okay? That's what we want. Okay? So now that represents the z, right? The z's by itself. Now we have y and z, and we have x, y, and z. So now the last step, which is the back substitution, right? So let me show you. So this is what we have. If you look at it as an equation again, which you can, all I did was bring over the coefficients and I attached them back to the terms that they match with. Remember, these represent the x values, these represent the y values, these represent the z values, okay? And these are the constants. So this is what it looks like. So here you can see z equals 2. Well, now if z equals 2 and we plug it into this equation, we should get y. And then if we plug it into this equation, we should get z. So that should be our answer. So let's get into it. Let me write the new matrix first, because I'm getting ahead of myself. But I wanted you to see how this works. It's pretty slick. So we have 0, 0, 1, right? Let me get, what was it? It was 0, 1, 3, 1, negative 2, 4. And then this is still 6, 0, and this was 2. Make sure I wrote that right. Yep, 6, 0, 2, 4, 3, 1. Yep, negative 1, negative 2. Okay, so now step 6, you're going to do back substitution. Okay, so this represents z equals 2, right? We said that this was y plus 3z equals, let me do it this color, sorry. Let me do it in black. So this is, this represents x minus 2y plus 4z equals 6. This represents y plus 3z equals 0, and then z equals 2. Okay, so if z equals 2, then you have y plus 3z equals 0. So you're going to have y plus 3 times 2, right? So that's going to be y plus 6 equals 0. Subtract 6, subtract 6. That goes away. And you're left with y equals negative 6, which we said that that's what that was. And then if z equals 2 and y equals negative 6, I'm just showing you because I want you to see how to substitute it back. Okay, so this is x minus 2 times negative 6, right? Plus 4 times 2 equals 6. Okay, so you have x minus negative 12 plus 8 equals 6. I don't know if y'all could tell that was a 2. So make that plus because they're right next to each other, minus. So this is now x plus 12 plus 8 equals 6. So that's going to be x plus, what is that? 20 equals 6, minus 20 on both sides. That cancels out, and you have x equals negative 14. So x equals negative 14, y equals negative 6, and z equals 2. Okay, remember this is an independent system because you have exactly one solution. So if you were to write your ordered pair, remember the order matters. So you'd have to write it like that. Duh, is on the screen. Okay, check your work. Go back to the original equation, plug these values in, and they will check out. Okay, I've already checked it for you. Now that's if you stop right there and then you want to back substitute. But you can continue to do row operations. You just keep going, and as you keep going, you'll get to the answer. This row, this column here, and the matrix will give you all the answers. So if you can get this diagonal where you have 1, 1, 1, and all the other terms are 0, you'll get to the answer. So when you get it going this floor where you have the ones in the diagonal and everything else is 0, that is called reduced row echelon form. Okay, again, without getting deep into matrix terminology, that's what it's called. So if you see it, that's what it's called, where you have a 1 in the diagonals, you have zeros everywhere else, because remember, this represents the x's, this represents the y's, and this represents the z's. And when you do that, that means your x value is equal to A, your y value is equal to B, and your z value is equal to C, and these will be the constants. Okay, so let's continue where we left off of on the one that we were working on. So I'm just going to grab this, and I just want to show you how you can keep going. So I'm going to copy this, and I'm going to paste it here. Okay, because you can totally keep going and get to the right answer. So as you can see with the row echelon, the reduced row echelon form, we need this to be a 0, this to be 0, and that to be 0. So you're going to continue to do row operations until all these are zeros, and then you'll have your diagonal, and then whatever numbers end up here will be the solution. Okay, so let's keep going. So what we're going to do first, and I'm just going to walk you through it. We're going to take -3 times row 3, and we're going to add it to row 2 to get the new row 2. Why? Because if this is a -3, when we add the 2 together, this will become 0. Okay, so we're going to take -3 times row 3, and we're going to add it to row 2 to get our new row 2. So if I take -3, times row 3, here's what we got. -3 times row 3. So I'm looking at this row right here, okay? So I'm going to keep my cursor there. So -3 times 0, that's going to be 0. -3 times 0, -3 times 1, and -3 times 2, -6. We're going to write down what our row 2 is. 0, 1, 3, 0. We're going to add them together to get our new row 2. Yep. So that's going to be 0, 1, 0, -6. Okay. So far, so good. Okay. So our new matrix, 1, -2, 4, 0, 1, 0, and then 0, 0, 1. Let me grab my constants. This is 6, -6, and 2. Okay. So far, so good. So now, oh, and then why did I start here first? Because I'm looking at where the ones are. Because I don't want these to turn back into 1. So I have to be very careful what rows I pick. You want to make sure that these kind of stay. Now, the ones I'm doing are working out really good. When you get in your homework, you might find some where you have to keep interchanging rows. You do whatever you have to do to get it. If you have one that you want to see, reach out to me and I can work through it so we can see it. And you can see how you just have to kind of maneuver it around, but it should be pretty straightforward. Okay, so then that's what we get there. Now, that's a 0. Now we want this to be a 0. Okay, so this looks good. This looks good. We have to make that a 0 and then make that a 0, and then we'll have our reduced row echelon form. So on this one, they said take -4 times row 3 and add it to row 1. Why? Because we don't want these to change, right? We don't want these to change. We just want that number to change. So that's what we focus on. So if I take -4 times this row, the zeros stay, which is great. This will become a -4. When I add the 4 with the -4, that will make that 0. Okay? So we're going to do, what is it? -4 times row 3. And we're going to add it to row 1 to get our new row 1. Okay? So -4 times this row. Okay? So -4 times 0 is going to be 0. -4 times 0 is going to be 0. -4 times 1 is going to be -4. And then -4 times 2 is going to be -8. So far, so good. I multiplied it by this row. I'm going to write down my row 1, which is 1, -2, 4, and 6. I'm going to add those together. And my new row 1 is going to be 1, -2, 0, which is what we wanted, and then -2. So far, so good. We almost done. We just got to do that last number. Oh, y'all see what I did? I copied. This should be 0. And then the constants are -2, -6, and 2. So now we just got to make that 0. Everything else looks good because there's zeros everywhere else. We have our diagonal. We just need that to be 0. And once we make that 0, whatever's left here will be our solution. So this one says take -2 times row 2 and add it to row 1 to get the new row 1. Why? Because we don't want this to change. So we need a row that has a 0. These both have a 0. And we don't want that to change. That needs to stay a 0. So we can't use this one, but this one works because then it won't change the numbers above it, okay? So we're taking 2 times row 2, and we're going to add it to row 1 to get our new row 1, okay? So 2 times row 2, this row here. Okay, so 2 times 0, 0, 2 times 1, 2, 2 times 0, 0, and 2 times -6, -12. Write my row 1, which is 1, -2, 0, -2. We're going to add them together, and we get our new row 1. So that's 1, 0, 0, which is what we wanted, and then -14. Yep. Cool beans. I'm like, yep, my PowerPoint better be right, huh? 0, 1, 0 and 0, 0, 1, which we knew this was the correct answer because we had already solved this matrix before we kept going further. But you see how this really works out. Okay, see how that works out? It really works out. So again, that's the system. That's the solution, to the system. And this is called the Gauss-Jordan method. Sorry, I didn't say that when we started doing it. When you go through these row operations and you get it into reduced echelon form, which is here, okay, where you have the diagonal and everything else is zeros, reduced row echelon form. This is called the Gauss-Jordan method. Again, without getting into the details of all of that, that's what this is called. So, types of solutions. I covered this in detail in the video where I do a systems of linear equation in two variables. I cover it in detail. Watch that video. And it'll make more sense. So just real briefly, when you're dealing with matrices, the concept is still the same. You'll want to watch that first video to kind of understand what I'm saying. But the concept is still going to be the same. When you end up with the reduced row echelon, that looks off. And you end up with one solution, that is called an independent system. Okay. When you have infinitely many solutions, what's going to happen is multiple variables will cease to exist. But you'll notice that the line that shows where all the variables are gone, because remember, if there's a 0, that means that term is not there. And this is what it looks like. You're saying 0x plus 0y plus 0z equals 0. Well, that's true because 0 times x is 0, 0 times y is 0, 0 times z is 0, so 0 equals 0. That's a true statement. When that happens, where multiple variables go away, but one of the rows shows this and it's true, then you have infinitely many solutions. Now, the inconsistent system is when you have no solutions. So it's sort of like the same thing happens. Multiple variables cease to exist, but then you notice if you have 0x plus 0y plus 0z equals 2, well, 0 can't be equal to 2, so that's false. So that's going to be like, okay, that's not true. So you would say it's an inconsistent system with no solutions. Again, I go over that in detail in the previous video where I do the system of linear equations in two variables. So check that out so you can get the details for that. Common mistakes is not following an order. If you don't have like an order, a step-by-step process that you're following, it's really easy to lose where you're at. So try to follow a specific order of steps so that you know where you're at and where you're going. Okay. Always check your work. Every equation, check your work. Remember, the solution has to fit every single equation in the system. Always check your work. Definitely check your work and check your work. Okay. And some key takeaways: matrices are so useful when you're solving system of linear equations. That way you don't have to look at all the variables and you're like, is it X? Is it Y? Is it Z? All you have to do is with the numbers. So that's what's really cool about the matrices, is you can just focus on the coefficients and the constants from start to finish, okay? Follow a system of steps consistently. The steps that I showed you seem to work well because you're just going in order. I would say whatever order you choose, just do it the same way every time so that you get used to it. You remember how it goes and you don't forget where you are in the process. And use the simplest method. Remember, don't make it hard, okay? Use the simplest method. Don't make it hard. If you can divide to turn something into a 1, divide it, okay? Don't try to add the equations, different rows and equations together, okay? And as always, you should be able to complete your assignment with success. Reach out to me wherever you have questions, okay? I am here to help. Write down what you're doing, show your work so that you can see what you're doing, okay? And then remember, at any point, you can reach out to me and ask me questions. I am always here to help. All right. Until the next lesson. Bye, y'all.